Hey guys, 7-5, solving square root and other radical equations. Whoops. We're going to go ahead and break this into the two different lessons just like we do in class. Let's go ahead and get started. All right, solving square root equations. Okay, with this we need to get that square root um, term by itself. So we would subtract 2, just like they've done here. And then once we've done that, we need to get rid of, undo, do the inverse operation of the square root, which is squaring both sides. So we square both sides, and then we are left with this two-step equation. Solve it for x, and voila, you are done. Okay, so now let's go ahead and do this one for your notes. And I had just attempted to do this a moment ago and had some difficulty, so let's start over. Okay, so we have -10 plus the square root of 2x plus 1 equals -5. So we want to get this by itself. We want to isolate it. So we're going to add 10 to both sides, which then this cancels, and we have square root of 2x plus 1 equals 5. Okay, this is now isolated. There's nothing else being added to, subtracted from, multiplied, divided. This is all by itself. So the opposite of a square root is to square it. So we're going to square both sides. The square of a square root cancels out. So now on the left we have 2x plus 1 equals 5 squared is 25. Now this is just a simple two-step equation. Don't overcomplicate it. We subtract 1 from both sides. And now we have 2x equals 24. Divide both sides by 2. And we have x is 12. Okay, now it is a very good idea to check your answer just to make sure it is something that's feasible, something that will work. Excuse me. So we take this 12 and put it in up at the top. 2 times 12 is 24. 24 plus 1 is 25. Can we take the square root of 25 and end up with a real answer? Yes. So therefore, we have our solution. Okay, moving on to example 2. Solving radical equations with rational exponents. Okay, excuse me. The only difference between example 1 and example 2 is the fact that they are presenting this to you with the fraction exponents as opposed to the radical symbol. Okay, don't be frightened. Excuse me. Okay, so now we have solved the expression 3 times x plus 1 to the 3/5 equals 24. We need to isolate this x plus 1 to the 3/5 just like we did on the previous slide. So we want to get this guy alone. All right, we need to get him alone. Oops. What's being done to this term? We're multiplying it by 3. What's the opposite of multiplying by 3? Divide by 3. So we divide both sides by 3. And this cancels. And now we have x plus 1 raised to the 3/5. And this equals 24 divided by 3 is 8. Okay, now looking at this, we want to undo the 3/5 power. We want to do the inverse operation. Excuse me. The opposite of raising something to the 3/5 is to raise it to the reciprocal. So we're going to raise this to the 5/3. So we raise that to the 5/3, and what we do to the left, we have to do to the right, otherwise it's an unbalanced equation, and we've altered the problem instead of just trying to solve the problem. Okay, now these cancel, and we are left with x plus 1 on the left, and then this equals. Okay, now I want to take a small detour over here, very, very small. The other day, we learned that this is your power. Ooh, and this is a hot mess, isn't it? And this is your root. Okay, so if we have 8 to the 5/3, writing that a little bit clearer, then we know that this is the same as the cube root of 8 to the 5th power. Okay. Now, when we take the cube root of something, will it give us a positive and negative answer, or will it give us just the answer that it is? And in this case, because it is an odd root, yeah, apparently I need to go back to first grade. Odd root, what you see is what you get. And I forgot the Y there. So what what you see is what you get. WYSIWYG. Whatever the answer is, that is what it is. If it's positive, you're going to have a positive root. If it's negative, you will have a negative root, because when you take the cubic root, the sign is what it is. Whereas with even roots, you can have negative times negative to get positive, or you can have positive times positive to get positive. So if that had been 8 to the 5/4, then we would have plus or minus as an answer. Okay? All right, back to what's going on over here. Okay, so we've just raised both sides to the 5/3 power. And we're left with x plus 1 on the left, and this is 8 to the 5/3. So you can either write it like we have here, or we can do 8 is the same as 2/3. So if this is raised to the 5/3, 8 to the 5/3 then is equal to 2 to the 3rd raised to the 5/3. The 3's cancel out, and we have 2 to the 5th power. So x plus 1 equals 32. Subtract 1 from both sides, and we have x equals 31. And that's your answer. Plugging it in just to check, 31 plus 1 is 32. Can you take the 32 raised to the 3rd power and then take the 5th power of that? 32 is even, so yes, you will have a real solution regardless of what the outcome is. Okay, I want to take a look at this one just as a bonus. All right, we've got 2 times the expression x plus 3 raised to 3/2 equals 54. So we want to solve the equation for this one. Right now we're multiplying this equation by this 2. So we're going to divide both sides by 2. The 2's on the left will cancel, and you have x plus 3 raised to the 3/2 equals 54 divided by 2 is 27. Okay, now this is isolated, so we're good. But we need to now solve it for this expression. We need to do the inverse operation, the opposite of 3/2. So we are going to raise both sides, because what we do to the left, we have to do to the right. We're going to raise both sides to the reciprocal power, so that's going to be 2/3. So these cancel, and we're left with x plus 3 on the left. And then this one is 27 to the 2/3 power, which is the same as the cubic root of 27 squared. Okay. Again, off to the side, 27 is the same as 3 cubed. 3 cubed raised to the 2/3 power. The 3's cancel out. So you have, this is 3 squared. So 27 squared, I do not know off the top of my head, but the cubic root of 27 squared is going to leave us with 9. Okay, so now we subtract 3 from both sides, and we have x is 6. Now real quick, the reason this is only 9 and not plus or minus 9 is because this was the cubic root. And when it's the odd root, we only have whatever it is that we get. Okay, now plugging 6 in up here, 6 plus 3 is 9. It's a positive value, so it's not going to alter the real or imaginary status of that number. Okay, that is it for the first part. Hope it's made sense. If not, let me know.